Today I'm going to be doing a tutorial for the turn board on wiring it with rotary potentiometers. I'm going to be using our standard 4x4 board, which allows 16 rotary potentiometers, but you can, if you've separated this board into a different configuration, you can do that as well. This is going to show you the basic connections and connecting it to the brain. For this tutorial, I'm using rotary potentiometers that I got from Mauser. You can use any 9mm snap-in rotary potentiometer with a linear taper. This is a 100K ohm potentiometer. There's a lot of different ones you can use out here. These are real cheap ones that with plastic shaft that I'm using for this tutorial, and I have 16 of them. The very basics you're going to need are this, obviously some soldering iron, and some wire. I'm going to be using these 2 ribbon cables. I'm also going to be using a breakout board. You don't need this for your tutorial, but this really helps you manage your wires and your connections. So I'm going to be using this as well, but the first part of it is just going to cover wiring this board and putting in the rotary potentiometers and connecting those to the brain. So the reason I'm using this 4x4 board, obviously we sell the 4x4, so that makes sense, but also because on our brain it allows 64 potentiometer connections or analog connections. It doesn't have to be a potentiometer, it could be some other kind of crazy controller, a distance sensor, touch sensor, but I'm using a rotary potentiometer because these are real popular and easily accessible parts and cheap. The brain supports 64 analog inputs, and this is nice because I have basically 2 rows. Each pin header on the brain supports 8 analog connections, and so I only have to use 2 pin headers by using these 4 rows of rotary potentiometers. So I have 8 connections here and I have 8 connections here, and that's how we're going to work with this project. So to start, you're going to need to locate some stuff on the board. The way these boards are designed is that they're perforated. They're V-scored so you can break them apart, so they're basically perforated boards. The nice thing about that is you could have any kind of configuration, so you're not limited to a grid or a specific shape or form. You can break them apart and do anything you want. So this means that all the connections on the board need to be jumped together to be able to use this as a continuous board. Now the way the turn board is laid out is it has these connections on all sides, so you can connect these on any side, any configuration. It's really nice, so you're not set to this configuration. I could just have a square here and take all these out in the center and still connect all these together. So you're going to want to locate some stuff on the board to be able to use this. Now this board also supports backlight LEDs, which are just basically LEDs that are always on, but for this I'm not going to do the LEDs. I'll do that in a different tutorial. I'm just going to be showing the rotary potentiometers. So the first thing you need to do is locate JP1 and JP2 on the board. JP1 and JP2 are going to be the first and second soldering connections here on the board, and JP3 is going to be the wiper. JP1 and JP2 are the ground and the voltage, and that's going to be common for 8 potentiometers. So all 8 potentiometers will use the same ground and voltage per pin header. So I can connect basically daisy chain these 8 for 1 ground and 1 power, and these 8 for 1 ground and 1 power. To run a jumper, you can use a wire, you can use a cable. What I use are the ends of capacitors and diodes that I've cut off, just a little wire. And here's a diode here, and I have actually cut a part of it off on this side. I have a lot of these sitting around, so this is what I use. And it's real simple. You just bend it in half, and then you run it through the jumper. So you want to connect JP1 to JP1 of this board, and JP1 to JP1 of this board, and then JP2 to JP2 and JP2 to JP2. So I'm going to go ahead and connect all of these. I'll show you an example of what you want to do. You want to connect all of them on the top side For the turn board, if you're going to use one of our other boards that require rubber keypads, you might want to do it on the bottom side. Actually, you're going to have to do it on the bottom side if you're using our rubber keypads because the keypads need to sit flush to the board. So there we go. I just wired a jumper, and you're going to want to go ahead and do that for JP1 and JP2 in these boards, all the way across all the rows, and then one connecting the two separate sections together. Now that I have all my jumpers connected, I like to run a simple continuity test to make sure that they're all connecting. So you want to start, now that the connections are going around this way and around this way, so these are separate daisy chain connections here, I'm going to take a multimeter and just do a continuity test. So when I touch these two, I'll get a beep. So when I touch the first pin and I touch the last pin, I should get a beep. And that lets me know that all the connections are okay all the way through the board. So my board is, all the jumpers are set, and now I am going to look at the back of the board here. You can see I have all these little pin connections coming out of the back. Hypothetically, it should be fine, leaving those there. But what I'm going to do is take these little wire snips here and just snip off the ends like so. Now that I have the ends all snipped off and I have a nice clean board, I am going to connect all my potentiometers. So to do this, there's holes for the pins that are connections. There's also these little snap-in holes, and those allow the potentiometer to stay in place, and they're really nice when you're soldering because you don't have to worry about anything moving around because they'll always stay there in place. You can also, you are actually going to want to solder the snap-in connections because it holds them down to the board. And if you've ever used a controller that has knobs on it, you'll know that sometimes the knobs can get loose. So this kind of holds them into place, so when you're moving your knob back and forth, it doesn't come loose from your board. You can also get metal potentiometers with a metal shaft. They're a lot more expensive. They're what we use in our controllers, and the benefit to the metal shaft is that they don't really wobble, and sometimes these plastic ones might seem like they don't wobble, but after a little bit of use, they start to wobble, and if you have any inexpensive controllers with knobs on them, you'll know that after a long time of use, your knobs will start to wobble back and forth. So you want to make sure that's nice and level, and you want to go ahead and solder each of these connections. So for these you have 3 connections. You have each of the pins, the ground, the voltage, and the wiper. And then you also have these snap-in solder holes here and here. And to give you a little bit of a better look there, what I'm going to do is, it would just be like soldering a connection. You just heat it up and make sure it fills up and you don't have any cold solder joints. So go ahead and solder all those connections, and then we are ready to connect to our breakout board. Now that I have all my potentiometers connected and soldered, I can go ahead and connect this board either straight to a ribbon cable, or I could connect some cables on here to connect it directly to the breakout board. Now the reason I'm going to be using a breakout board for this example is because we've designed the breakout board to work with our boards to make everything much more manageable and easier to use. So you don't have a lot of wires running all over the place, and everything is easily traceable, and you can see how everything works together. So what I'm going to need to do is take JP3. There's JP3s on 4 sides of this board to make it easier to work with. So I'm going to take a JP3 from each potentiometer and wire it directly to the breakout board. Now the breakout board has a spot for 8 potentiometer pin headers here. So you can wire 8 to each of these to give you 64 potentiometers. Now, since we're only using 16, I'm going to use the first 2 breakout boards for the potentiometers. And this is a complete breakout board, but you can also break this apart. It's V-scored, so you can break this apart. If I only wanted to use 2, I could just use these 2. So I'm actually going to go ahead and break the perforation here on 2 of these. And they're all identical, so I'm just going to use these 2. So now I have a smaller breakout board. I have my 2 potentiometer breakout here, and I am going to go ahead and just use this. Now, since the potentiometers are going to have one connection going to one connection here on the breakout board, and then I'm going to have, since I have 2 sections of potentiometers here, 8 and 8, they're going to each have a ground and voltage that go to the breakout board as well. So there's going to be 2 sets of ground and voltage and 16 wires for the wiper signal for the potentiometers. So the first thing I'm going to do is use the wiper signal. And for that, I'm going to use a just a standard single strand cable here. They're really easy to work with, and that's why I chose this. And I chose green because for all the wiper signals, I'm going to use green, and for the ground, I'm going to use black, and for the voltage, I am going to use red. That way I can tell the difference when I have all these wires coming off of here. I'm going to connect the wiper connection from each potentiometer to the breakout board. Now the breakout board has a spot for 8 potentiometers and a pin header. Now this pin header, you can just run a ribbon cable from this to the brain, so you don't have to have crazy wires all over the place, and when you're working with your projects, you can just use these ribbon cables to plug and unplug. It's advisable to use these kinds of connections because it's just going to make things a lot easier down the road, and you can have different configurations, different setups, and use the same brain. So now what I need to do is locate the wiper signal, and I'll show you an example of how to do one, and then we can go ahead and populate everything. I'm going to take my cable here, and you might want to cut your cables a little bit longer, but for this example I'm using these kind of small cables so I can fit it all in the frame here. So you want to locate JP3. You can use JP3 on any part of this board here. I could use it on this, I could use it on this, I could use it on this, but I'm going to use it on the pin that's right next to JP2 because I want to show you how this is JP1, JP2, and JP3. Again, I could use this JP3, I could use any of these JP3s on this board because they all share the same connection. So I'm going to go ahead and solder that. And then I'm going to locate the first potentiometer on here. I'm going to start with this side on the left. And I'm going to go ahead and solder it into the right connection on here. So now I have my 1 potentiometer wired to my breakout board. Again, in the breakout board, this is JP1, JP2, and JP3. The last 2 are for positive and negative for the backlight circuit, but we're not going to have any LEDs on this right now. We're just going to have our potentiometers hooked up. So I'm going to go ahead and populate this for the rest of them. Now it's important to note that the way I numbered these, so I know that this one goes to 1, 2, 3, 4, 5, etc., is that I'm just starting here and working my way across. Really, it doesn't matter how these are wired as long as they're all connected, as long as these daisy-chained ones go to this board and these daisy-chained potentiometers go to this board, because you can use the editor software to reconfigure all these MIDI settings. So you might want to do them sequentially so you know where everything is, but in the end everything can be remapped in the software and saved to the brain, so you can reprogram these control numbers to be whatever you want. Now I have this section of the potentiometers wired to the breakout board, each going to the center wiper pin from the JP3 pin of the potentiometers. I'm going to go ahead and do the second section, which would be all these that are unwired. Now I have the breakout board connected to the turn board, and you can see that all of I have 16 wires which are all going to the center pin on the breakout board, which is the wiper. Now I need to go ahead and wire positive and negative connections for each. To wire the ground and the voltage signal from the turn board to the breakout board, this is pretty simple. Now you're just going to need two cables. So I have a red cable here. I'm going to go ahead and cut myself a piece of that. I'm actually going to want to cut two because I'm going to need two pieces. And I have black, which I'm going to use for my ground. And remember, we have two sections here. So this is one section and this is the other. Now, they all share, since I've daisy chained them all together, they all share a common ground and they all share a common voltage. So the voltage and the ground only need to be wired to one connection on each section. So I'm going to go ahead and fine-tune places where I'd like to do this and solder it together. So I'm just going to use this top connection here. JP1's ground, just so you remember, for most cases on the brain and our components, JP1's ground. So I'm going to go ahead and connect JP1 to ground and JP2 to voltage. And I'm going to do the same for the other section. Again, I could choose any side here to connect to. I could connect even in the center because they're all daisy chained together. I'm just choosing these outer sides because it's a little easier to connect to. You can solder from the top or the bottom. It really doesn't matter. I'm choosing the top here because it looks easier for this demonstration. And you can see why I like to use this single wire here because it's real stiff and easy to work with. It's probably not the most reliable over time, but this is a DIY project, and if something goes wrong, we can go ahead and fix it. So taking a closer look at this, I know I have section 1 here going to this board, and I have section 2 over here going to this board. You can always tell what are your sections because you'll notice down the center none of these are connected, meaning this board is now separate from this board. So there's no daisy chains here. All the daisy chains happen within here. So you can see all those daisy chained areas. So now this is the first board that has all these connections to it. Since these are all already connected on the inside, you only need to wire to one of the sections. These are called CCs here for the continuous controller. You only need to wire to and solder to one section of these. So I'm just going to choose this one closest to the pin header, which we haven't populated yet, but we'll get to that. And here we go. And I'm going to go ahead and solder that connection. Now you'll notice we still have all these pins sticking out here. We're going to go ahead and go back and snip those off before we're done our project. I have this first section wired. I'm just going to take these two, and again, JP1 is pin 1, and JP2 is pin 2, which is going to correspond to voltage and ground. Ground is always going to be pin 1. And there we go. We're all set. So now we have our board wired, and the nice thing about having this might look like a big mess of wires, but you can easily trace everything back. And this kind of can compact against here. So if you're making an enclosure, this could sit really close, and you would have very little problem with clearance here. All these wires can pretty much sit right on top of one another. We're going to go back and snip all these little areas. This isn't required, but it's just a good way to make sure your work is clean and you're not going to have connections touching one another. Now that we've connected everything, we need to connect the pin headers to the pin header area of the breakout board. The best way to connect pin headers is to buy a set of pin headers. You can buy them pre-cut. I like to use these, I think there's 100 pins on here. The nice thing about this is I can use it for any size pin header. I can just cut it to the size that I need. So to do that, I'm going to take a razor blade and my pin headers. You can also use a scissors or snips, but I like to use a razor blade because then I can make sure I'm using all of the pin headers and not have any waste. So all the potentiometer connections use 10 pins, so you just need to count 5. 1, 2, 3, 4, 5, and what I'm gonna do here is just score this a little bit, and I should be able to break it apart. So there we go. I have my pin header. So I got my 10 pin header. Again, buying it like this is cheaper than just buying this. So I've already cut the other one. So I'm going to take the pin header, and now I need to solder the pin header to the board so I can connect it to the brain. You'll see the pin headers fit in nicely right here. And what you're going to want to do is get them into place. And you might want to put a piece of tape or something over it to hold them into place. And you're going to solder them from the back. Make sure they're straight before you solder, because they're real hard. Once you solder these things down, they're really hard to get off. And everything just to connect the potentiometers to the brain is in place, and we are ready to go ahead and get our ribbon cables and connect to the brain. So now I'm going to take these pin headers here. They're 10 pin headers, and locate 2 10-pin ribbon cables, and I'm going to connect these to the brain. So with the brain, we use these 10-pin pin headers here to connect the potentiometers to all these. There's 64 available contacts. Since we're only using 16, we only need to use 2 of these pin headers. So it starts at JP7 here, so I'm going to use JP7 and JP8. So I'm going to connect these 2 pin headers to these 2 pin headers, and we should be ready to go. So one thing with the ribbon cables, you need to make sure that this red line, which indicates pin 1, is lined up with the arrow on all of the boards actually. So I'm going to take this, I'm going to line up pin 1 here, and then I'm going to line up pin 1 here. You can see the arrow is right here on JP7. And I'm going to do the same thing for JP8. Take the red line, line it up here, and the red line here, and line that up. So now I'm connected. I have my potentiometer controller connected to the brain, and all I have to do is open up the software and configure it, and my brain should work. So let's go ahead and open up our configuration utility. Now that we have everything connected, we need to go ahead and open up the brain configure application and set the brain so it knows that we only have 16 analog potentiometers connected and nothing else. Because right now the only thing we have connected is these 2 pin headers, so we need to tell the brain these 2 pin headers are connected directly and nothing else is connected. So go ahead and open up your brain configure application. Press the hardware configuration button, which will open up the hardware configuration interface. And in the analog section, which is the potentiometer connections, we are going to select 16 as our number of analog controls, and the first 80 jumper index is going to be JP7, which we have connected here. Now it's worth noting that you could go into the analog map and change all the settings for your controller, but we're just going to leave it at the default value because it doesn't really matter for this tutorial. So go ahead and set that and press send, and you'll see this turn green. That means it's been sent, and click save to brain. Save to brain again will save everything to the internal memory of your brain. So now that I have that saved and going, you can open up a program like MIDI Monitor, and you will see when I move my potentiometers, you'll see I'm getting values now. So here we go. I have my potentiometer moving, and everything seems to be working just right. So I'm going to go ahead and do something with it. I am here in Ableton Live, and I'm just going to play a track and use this to put some effects. So I'm going to go ahead and put MIDI Learn on. So I can use these to control different parameters. So that's it. That's my tutorial for wiring and configuring the turn boards with snap-in 9mm rotary potentiometers and wiring it to the breakout board, which then is wired to the brain. Thanks for watching.